All right, hey everyone. So I just wanted to go over a couple of things. We've been talking about arithmetic and geometric sequences and their differences, and I wanted to just review for this first slide. So remember that arithmetic sequences, they are involving addition and subtraction when you are looking at sequences. And the common difference is how we identify the pattern of a specific sequence if you look down here at this example. So here's an example. Let's say it goes 3, 7, 11, 15. Remember, this is the first term. This is the second term, third term, fourth term, and so on. So to find the constant difference or the common difference, you take both terms that are consecutive right next to each other, and you basically subtract them from each other. But in order to do this, you have to take the 7 and then take the 3 away from the 7. So that's how we find the common difference, and 7 minus 3 we know is 4. And you'll continue to do that for each of the other differences between two terms. So 11 minus 7, and then 15 minus 11. Now for geometric sequences, those patterns and sequences involve multiplication and division, and it is called a common ratio or a constant ratio, which is also known as the growth factor. If you look at this example at the bottom, the growth factor here is 3. Because the pattern each time you're taking the first term and timesing 3 to get the next term and continuing to times 3. Now in order to find that, we use division to find the ratio. But we don't do 3 divided by 9, we do 9 divided by 3 to go backwards, and we know that that's 3. In order to check again, we take 27 and divide it by 9, and we continue to get 3. So we know the growth factor for this sequence is 3. Now here, if we look at this example, this was a question on the last checkpoint, and I just wanted to review it. First thing, as you could tell at the top, I wrote in green the term number. So if the number is first in the sequence, that's the first term. And then the next one is the second term, and the third term, and then the fourth, and so on. This example had decimals, so you want to be careful that you understand the decimal is in that number that doesn't separate it. So this is not 8 and then a 25. This is 8.25. So for arithmetic, we use subtraction in order to identify that common difference. So what you do is you take two terms that are right next to each other, for example, the 8.25 and the 12.25, and you have to find their difference, so you have to subtract them. So you take the second number minus the one right before it, the first number, and you find what they're equal. And when you subtract these, you'll see that their difference is 4. To continue to check that, we look at the next two terms, the next two consecutive terms, and that would be the third term, which is 16.25, minus the second term right before it, which is 12.25. And if you find that difference and you subtract them, you're going to get 4 again. And already we can tell that they're the same, but we're going to check one more time, one more difference, to see if it's also 4. So take the next term in the sequence, 20.25, and subtract the previous term, which one is right before it, is 16.25. And when you take your calculator and you plug those into your calculator, you'll see that it's 4. So if you want to check these 3 like I just did in your calculator, go ahead and pause the video so that you can check to make sure you're able to do that. Next, we already know that the sequence is arithmetic because those common differences are the same. We know it's arithmetic. So we can go ahead and say this is arithmetic. But just to verify that it's not geometric, we go ahead and we actually do the work to see if the common ratios are the same. So for geometric, remember we are dividing. So we take the second term, which is 12.5, and you're going to divide by the term right before it, which is 8.25. Which in your calculator, you'll see a long decimal. We're just going to round it to the nearest tenth. So we're going to say it's 1.48. Let me write that a little bit clearer. All right, so that's the first ratio that we see. Next, we're going to check the next ratio between the next two terms, which is the second and third. But remember, you start with the one after and divide it by the previous one, not one earlier in the sequence, the one right before it. So if we take 16.25 and we divide that by 12.25, we'll get another long decimal, and we're going to round it to the nearest tenth. So we're going to say it's 1.33. Already, we can see that these two are different, so we know it's not geometric, but we're going to check the next two terms, the third term and the fourth term. So take the fourth term and divide it by the third term. And when you plug that into your calculator, 20.25 divided by 16.25, you get another long decimal, and this one is about 1.25. So you can see that we did the same terms here and with arithmetic, but we actually use subtraction when finding their difference, and then we use division when finding the ratio. And because these three numbers are different, we know the sequence is not geometric, it's actually arithmetic. All right, so for this example, we're going to do the same thing we just did on the previous slide. So we're going to look at arithmetic to begin. Remember that the place in the sequence determines the term number. So the first number of the sequence is the first term. The second number is the second term, the third, and then so on. Okay, those are the term number for term. All right, so for arithmetic, remember we are subtracting to find the difference. So you take the second term minus the first one. So 9 minus 3 is 6. You take the third term minus the one right before it, which is 9. And 27 minus 9 is 18. And already we can see that these two are different, but let's check the third one. Take 81 minus the term right before it to find the difference. And 81 minus 27 is 54. So already we know that it's not arithmetic. So let's check geometric. Take the second term, divided by the term right before it, which is 3. And 9 divided by 3 is 3. Okay. Take the next term, which is 27, the third term, divided by the term right before it, which is 9. And let's see what that ratio is. 27 divided by 9 is 3. So already we see that they have the same ratio. But let's check the last one. 81 divided by 27. And if you put that into your calculator, you'll also see that that's 3. So we know that this sequence is geometric. And eventually you'll get good at just looking at the sequence to start. And we know that this one is increasing pretty rapidly from 3 to 81. So that's a good educated guess that it may be geometric using multiplication and division. All right, here's a new example. If you want to try this before I go over it, go ahead and pause the video. If I'm giving you a sequence of numbers, remember, make sure first you can identify the terms and don't get confused by these decimals, right? So the first term is 4, then 6.2, then 8.4, and then 10.6. Now, we need to find the common difference to check if it's arithmetic, or the common or constant ratio to check to see if it's geometric. If we find that in the common difference, there's all the same numbers for the difference, then we know it's arithmetic and we don't have to check the common ratio. So let's just start. Remember, when we find the difference, you start with the next term, which is 6.2 minus the term right before it. And 6.2 minus 4 is 2.2. Then find the next difference between the two terms, 8.4 minus 6.2. And we also get 2.2. So already I'm seeing that it has the same difference, but we need to verify one more time. So take 10.6 minus 8.4, and we get 2.2. So we don't even have to check to see if there's a common ratio, because if there's a common difference, there's not going to be a common ratio as well. So for this one, because we see that it's 2.2 for the difference between each of those numbers, we know that this sequence is an arithmetic sequence. All right, for this slide, I wanted to just review a little bit about growth factors and how a sequence is growing or decaying. And so when you're looking at sequences that are geometric, the common ratio is also known as the growth factor, and you want to write that down. The common ratio is also known as the growth factor. So it's important to know if you're told that the growth factor is greater than 1, and we'll go over some examples, then you know the sequence is increasing. If the growth factor is less than 1, then the sequence is decreasing. And if the growth factor is told to equal 1, then you know that the sequence is remaining constant. So these are 3 pieces of notes over here that you'll want to write down, or just remember if the growth factor is greater than 1, it's going up because it's greater than 1. If it's less than 1, then it's going down. All right, here's an example similar to the one, I don't know if it's an example that was on your checkpoint on the back, but it says a geometric sequence has a growth factor of 2 and an initial value of 5. Now, what you want to be careful of, it doesn't matter what you're starting at with the sequence. What matters is the growth factor. And in this case, it's telling you that the growth factor is 2, and we know that 2 is greater than 1. So if you look on the previous slide, when the growth factor is greater than 1, we know that the sequence is increasing without even finding the next numbers in the sequence after it starts at 5. In this example, it says a geometric sequence has a growth factor of 0.8, which is important because we're talking about growth factors, and an initial value less than 1. It does not matter that the initial value is starting less than 1. What we're concerned about is the growth factor. And here, like I said, it's telling you that the growth factor is 0.8, and we know that 0.8 is less than 1. Therefore, the sequence is decreasing.